Force is the product of mass and acceleration, represented by the equation F equals ma, where F represents force, m stands for mass, and a for acceleration. In SI units, mass is measured in kilograms and acceleration in meter per second squared. So force has units of kilogram meter per second squared, which is equivalent to 1 Newton. In English or imperial units, force is expressed in pounds foot per second squared or pounds force. In engineering mechanics, force is defined as an action that changes or tends to change the state of motion of a body. But to fully analyze the effects of a force, we need to know three of its fundamental characteristics. First is magnitude. It is the quantitative measure of a force which tells us how strong a force is. The direction of a force, which is indicated by the orientation of the arrow. And finally, the point of application of the force. Together, these characteristics determine how the force influences an object. One of the fundamental axioms of mechanics is the parallelogram law of forces, which states that the resultant of two forces acting at a point is represented by the diagonal of a parallelogram formed by the two force vectors. So if we have two forces, F1 and F2, we can construct a parallelogram by drawing lines parallel to each vector from the tip of the other. Then, the resultant of force R is given by the diagonal of this parallelogram starting from the common point of application. This resultant force is a single force that has the same effect as applying F1 and F2 together. In other words, a resultant force represents the combined influence of both forces in terms of magnitude and direction. This is the basic idea of a resultant force. We will explore how to find the resultant of a more general force system in a separate video. Now let's say F1 is equal to 8.5 newtons and F2 is 11 newtons at 45 degrees from x-axis. While we can find the resultant R graphically, it's often more practical and certainly more accurate to solve it mathematically using trigonometric functions. You will notice that the parallelogram naturally forms two symmetrical triangles, with the resultant force R running through the center. We can use either of these triangles to solve for the magnitude and direction of the resultant. And the most effective way to solve for sides and angles of a triangle are the law of cosines and the law of sines. As a quick reminder, the law of cosines describes the relationship between the sides and angles of any triangle. It states that the square of one side is equal to the sum of the squares of the other two sides minus twice the product of those two sides and cosine of the angle between them. While the law of sines states that the ratio of the length of a side to the sine of its opposite angle is the same for all three sides of a triangle. Now let's go back to our example. Since we're dealing with a parallelogram, the opposite sides will have the same magnitude and direction. So this vector is also 11 newtons at 45 degrees from the x-axis. The angle opposite to R is 180 degrees minus 45 degrees since they are supplementary angles. That gives us 135 degrees. Now we have two adjacent sides, 8.5 newtons and 11 newtons, and the angle between them is 135 degrees. We can now apply the law of cosines to solve for the resultant force. Substituting the given values, and solving for R, that gives us 18.04 newtons. Now let's find the direction of the resultant force relative to the x-axis. Since we know the value of r and its opposite angle, as well as the side opposite to angle theta, we can use the law of sines to solve for the missing angle. So sine theta divided by the opposite side 11 newtons is equal to sine of 135 degrees, divided by the resultant force, which is equal to 18.04 newtons. And solving for the angle theta, we get 25.54 degrees. So the resultant force has a magnitude of 18.04 newtons at approximately 25.54 degrees from the x-axis. Before we continue, if you're finding this video helpful, make sure to give it a like and hit that subscribe button so you don't miss out on more engineering tutorials like this. The parallelogram law of forces is also the backbone of understanding how to resolve a single force into two components. Only now we will start with a single resultant force and work backward to find its components. Components are the individual parts of a force that acts along chosen directions. Each component represents how the force influences that specific direction. When combined, the components reproduce the same magnitude and direction as the original force. A force can technically be resolved into different pairs of components at various angles. However, in most practical situations, it's most useful and convenient to resolve a force into rectangular components, one along the x-axis and the other along the y-axis. These components form a right triangle with the original force P as the hypotenuse. To find the magnitude of the components, we can use basic trigonometric functions. Now let's say the force P acts at an angle theta from the x-axis. We can solve for the horizontal component px using the cosine function. Cosine theta is equal to the adjacent side px divided by the hypotenuse p. Therefore, px is equal to p cosine theta. Similarly, the vertical component py can be found using the sine function. So sine theta is equal to the opposite side divided by the hypotenuse p. So py is equal to p sine theta. It's interesting to know that when we apply the law of cosines and the law of sines to solve for the rectangular components, we naturally end up with the same relationships found in the Pythagorean theorem and the basic trigonometric functions. Let's say the force P is equal to 15 newtons and the angle theta is 30 degrees. The horizontal component Px is equal to P cosine 30 degrees, so therefore Px is equal to 43.3 newtons. And the vertical component Py is equal to P sine theta, which is equal to 25 newtons. So the force 50 newtons acting at 30 degrees from the x-axis has a horizontal component of approximately 43.3 newtons and a vertical component of 25 newtons. And that's it for the introduction to forces and components. Don't forget to like and subscribe. See you in the next one.